Hello everyone, welcome back to Pachehra Talks channel. My name is Arun. I'm solutions architect with Rackspace Technologies, which is one of the best organization to work with. And today we are going to talk about design a data integration solution with Azure Data Lake. We have covered Data Factory, and this is time to check out Azure Data Lake. All right, so first of all, we need to understand Azure Data Lake storage first. So what is the Azure Data Lake? Well, if we need to define Azure Data Lake is a repository of data that is stored in its natural format, usually as blobs or files. Data lake storage is a comprehensive, scalable, and cost-effective data lake solution for big data analytics built into Azure. Data lake storage combines a file system, that's the beauty, with a storage platform to help you quickly identify insights into your data. You can easily understand this because whenever we go and create Azure Data Lake storage, we just need to check a box which enables the file system. So Data Lake Storage Gen 2 builds on Azure Blob Storage capabilities. So it has both the features of Azure Blob Storage and of course file systems to optimize it specifically for analytics workloads. This integration enables analytics performance highly available, secure, and of course, durability of storage. The current implementation of Azure Data Lake storage services is Azure Data Lake Gen 2. We do have the Gen 1 as well, but now Gen 2 is what we focus. Because of cloud and the amazing services, including unlimited cheap storage, ETL is now ELT. ETL extract transform load, we have covered this in previous videos, even in the data factory, and ELT is extract load and transform. We did cover the difference between these two, why is better, why is one is good, when we have to choose one over another. And to go with the ELT process, Azure Data Lake has an important role to play. So that's what the Azure Data Lake storage is. It's a storage for the big data in very simple terms with hierarchical namespace, which enables the file system, and HDFC can directly access this Hadoop file system. So that's what the Azure Data Lake storage in high level understanding is, and this is what we needed in order to understand and put it in our architecture. So what is next? Next, we need to see, because this is a concept, a big picture that we have in our mind for data lake storage, but now it's time to check features. It's time to check important features of Azure Data Lake. The very first is data storage. Azure Data Lake storage can store any type of data by using the data's native format. You just upload the raw data, it would be there as it is. With support for any data format and massive data sizes, Azure Data Lake storage can work with structured, semi-structured, and unstructured data. Now let's check the second feature, which is data access. Azure Data Lake storage primarily designed to work with Hadoop and all frameworks that use the Apache Hadoop distributed file system as their data access layer. Azure Data Lake storage is priced at Azure Blob storage level, so it's cool. Data Lake storage supports high throughput for input, output, intensive analytics, and data movement. Lake storage access control model supports both RBAC and portable operating system interface for Unix POSIX, access control list ACLs. We talk about the redundancy. It has all those redundancy that Azure storage has. Scalability. Azure Data Lake storage offers massive storage and accepts numerous data types for analytics. And data analysis frameworks that use HDFS has their data access layer can directly access this, because it was, as I said, primarily designed to work with Hadoop. These are few features which makes Data Lake amazing. And because of these features, we can utilize Data Lake in our ELT processes or analytics processes, storing all kind of data coming from various sources. Now, if we check the usage, when you need a data warehouse on the cloud for managing large volumes of data, like when to use the ADL storage, this is one of the requirements. Azure Data Lake storage runs on virtual hardware on the Azure platform, making storage scalable, fast, and reliable without incurring massive charges, because it charges like a blob. It separates storage cost from compute cost. As your data volumes grows, only your storage requirement change. So that's a great description. And another requirement, when you need to manage a diverse collection of data types, such as JSON files, CSV, log files, or other diverse formats, Azure Data Lake storage enables data democratization for your organization by storing all your data formats, including new data, in a single location. Eliminating data silos enables users to use a tool such as Data Explorer to access and work with every data item in the storage account. And when you need real-time data ingestion and storage for analytic services, real-time Azure Data Lake storage can ingest real-time directly from an instance of Apache Storm on Azure HD Insight, Azure IoT Hub, Azure Event Hubs, or Azure Stream Analytics. It also works with semi-structured data and lets you ingest all your real-time data into your storage account. So these are some requirements where we can think and opt for ADL for the use. And let's see a couple of use cases for ADL, or Azure Data Lake. IoT data movement, big data processing, analytics, reporting, on-premises data movement. We can utilize ADL features for these kind of use cases, because a complete data lake solution consists of both storage and processing. If we think broadly, think a big picture, data lake storage is designed for fault tolerance, infinite scalability, and high throughput ingestion of data with varying shapes and sizes. Data lake processing involves one or more processing engines built with these goals in mind and can operate on data stored in data lake at scale. Now, we have seen the use cases, and it's time to check out the advantages of data lake. Data is never thrown away because the data is stored in its raw format. This is especially useful in a big data environment when you may not know in advance what insights are available from the data. Users can explore the data and create their own queries, maybe faster than traditional ETL tools. More flexible than a data warehouse because it can store unstructured, semi-structured data. Check out few challenges. Lack of schema or descriptive metadata can make the data hard to consume or query. Lack of semantic consistency across the data can make it challenging to perform analysis on the data unless users are highly skilled at data analytics. It can be hard to guarantee the quality of data going into the data lake, and without proper governance, access control, and privacy issues can be problems. What information is going into the data lake, who can access the data, and for what uses? We need to plan for all these. It requires more work for governance. A data lake may not be the best way to integrate data that is already relational, right? By itself, a data lake does not provide integrated or holistic views across the organization. A data lake may become dumping ground for data that is never actually analyzed or mined for insights. These are few challenges, and this is the architecture that we will go through in our next video. Till then, take care and bye-bye.